Hello, ladies and gentlemen. So today we are talking about cylinders, and we're going to be looking at surface area and volume again. You need your flip chart notes, a calculator for sure, okay, and something to write with. Remember to write surface area examples and volume examples as well as the formulas into your little flip chart, okay? We're going to walk through where they come from a little bit, but the idea of using a formula is what I want you to get. So remember, this is where we're writing our notes. You have a page devoted just to cylinders. So let's take a look at how the surface area of a cylinder would work. So cylinders are like prisms, except they have circles for bases. So maybe you want to write that on that page when you open it up in your notes. We're talking about treating a cylinder just like prisms, except that they have circles for bases. So if we take a look at what that looks like, yes, if this was a square on the bottom or a rectangle, it would be a cylinder, it would be a prism. But because that curved surface is now there, it makes it into a cylinder shape. So we have a circle on the bottom, a circle on the top, and if you've ever taken a look at like a soup can label or something, it's really a rectangle that goes around. So it would look something like this. We have a circle on the top, circle on the bottom, and a rectangle that makes up that cylinder. Now we know how we can find the area of the circle, right? Area of a circle is pretty easy. Pi r squared. And we would have two identical circles, pi r squared. But how would we find the area of this rectangle? Well, think with me, the rectangle is as long as the circle's circumference. Remember, this rectangle would wrap around making a cylinder. This would be the circumference length from here to here. And then this would be the height of that cylinder right here. So how do you find circumference? Well, that's 2 pi r. So if I wanted to find the area of this rectangle right here, it would be 2 pi r times height. So if we sort of sum this up, we have two circles. They are pi r squared. So we'd have something like 2 pi r squared, and those would be the areas of the bases, plus the perimeter of the base would be the circumference, right? Because that's what the perimeter of a circle would be. We'd have 2 pi r times the height of the cylinder, which would be h. So we can use this formula for surface area of a cylinder. So one more time, it's the same formula as prisms, 2 area of the base plus perimeter times the height. But we know the area of the base is going to be pi r squared because it's a circle. And we know the perimeter is 2 pi r because that's the circumference or perimeter of a circle. So this is the surface area idea for cylinder. Now how can we use that to solve a problem? You'll find that these are really pretty quick to solve. So let's go ahead and do the surface area of this cylinder. Draw it as best you can. That's 4 feet and 3 feet. So if I were going to use my formula, it's 2 pi radius squared plus 2 pi r circumference times the height. So let's plug in what we know. 2 pi, the radius is 3 squared, plus 2 pi, the radius is 3, and we're going to multiply that times the height. So we have two things going on. First, we can calculate this part, 2 pi 3 squared. So we could go ahead and type that in a calculator. You can leave it in terms of pi if you like. This would be 9 times 2, 18 pi's. Okay, and then on the other side here, you would have 12 plus 2 more, 24 pi's. So 18 pi's plus 24 pi, we can leave it in terms of pi if we want to. We would have 42 pi. Now if I wanted to get a decimal approximation for that, 42 times pi, we could go ahead and calculate in our calculator. 42 pi would be about 131.9 feet squared. Okay, surface area, square feet. So that's how I would use that formula to find the surface area. Now what about volume? Well, volume is relatively similar as well. Think about the volume of a prism, area of the base times the height. Again, the base just happens to be a circle this time. So it's like we're piling up all of these little circles to make the entire height. So the volume formula is area of the base times the height, or since we know the area of the base is pi r squared, we can go ahead and plug that in where the b is. So if I was going to do a volume example here near this formula, I'll just do the same cylinder we had before. And let's just calculate the volume this time. So volume equals area of the base, pi r squared, times the height. So if I plug in what I know, the area of the base here, I'm going to plug in a 3 for the radius, and the height would be 4. So if I left it in terms of pi, I'd have 9 here for 3 squared times 4, 36. So I'd have 36 pi. But again, if I want to multiply that out, 36 times pi is actually 113.1 roughly cubic feet. Now you might say, well, that seems weird because the surface area was actually a larger number. Remember, we're talking about different units here. A cubic foot is a foot by foot by foot cube, okay? It's three-dimensional. Whereas a square foot is, similar to a sheet of paper, if you will, or something flat like that that you're covering the figure with. So the units are different, therefore we don't worry so much about the fact that the one number is bigger than the other or vice versa, because the units are completely different, okay? So volume is 113.1 cubic feet. So we found the surface area and we found the volume of a cylinder. Circles, while they're curvy and have a pi involved, are actually kind of nice to deal with surface area and volume on these things, okay? So I want to thank you for taking good notes and filling in those 2 pages. More pages to come, right? More shapes to come, but we'll just work with these for a little bit, all right? Again, thank you for taking good notes. Kincaid out.